so I haven't done much. So I wanted to ask everybody whether anybody had a chance. I think the basic thing we had discussed last week was the paper from Nature, and then said let everybody download the data and get at least the data set up to where we can start playing with it. I don't know whether anybody had a chance to do. Everybody had a chance to do that yet.
I tried to download it. Data. The download was fine. However, I was not able to unzip the file. It's
Right.
I spent around 2 days like leaving my laptop on day and then nighttime as well. And strangely enough, now it's my kernel is stuck somewhere, and I cannot even mount my personal drive on any of the notebook. It's got stuck somewhere. So
Were you were you using Colab, Dinesh?
collab, yeah, yeah,
Actually, the thing that I found in Colab, I posted on the chat before that, yeah, download is just 17 and a half gig, but I ran into similar problems like yours multiple times. What I had to do that I figured out is, um, first of all, for whatever reason that I fail to understand, unzip takes about 50 plus gigabyte while it is unzipping, even though the end result is only again another 17 and a half gig.
yeah,
So that makes it necessary, at least I found on
yeah,
Google Colab, or I forget, sorry, I had to subscribe to about 100 gig on Google Drive
yeah,
and then unzip using that. And even that took me, as I mentioned last time, about multiple hours, 4+ hours, 4.5, 5 hours for
yeah,
it to unzip successfully. And also, I couldn't just leave the machine running because Colab kind of um, shuts the window if it isn't active. So
yeah.
I had to kind of do it during a period when I could, periodically kind of refresh it in the sense of not doing anything, but at least not letting it go to sleep.
Yeah, I'm like I read the whole thread, so I try to do the same. I had this small snippet here, and then which doesn't let the laptop sleep. So interestingly, when you unzip, and I have around 70 gig left on my Google Drive. What I notice is it uses your trash folder. So when it unzip it, I think it throws that into your trash folder. So I kept on tracking, and then in your on your kernel on a Google Colab, it does show you, I think, on the bottom
Yes,
left corner how much GB left.
yes, yes. And I was down to about like less than 5 or 4 by the
It's,
time it unzipped everything. And by the way, one thing that worked for me was I see, and I think somebody else, maybe Steve, had posted, or somebody on the chat had also posted that maybe it was you, that it left the files corrupted. So the first time I tried and it failed, I deleted it, re-downloaded the zip, and did it in one go, and that's what worked for me.
yeah, so it's exactly, I'm going through the same thing. First day went on where zip file, there was error in a zip file reading on a zip file.
Right,
So
right.
it happened a few times, and then I said, okay, let's start from scratch. I delete everything, cleaned everything, and then I started again, and then again I'm stuck there. So I'm just and I can still open interesting part is when I go and then open my the kernel on the collab, I could still see for that GPU, that particular notebook, it shows me the disk space 3/4 covered. But when I changed my kernel to CPU or TPU, the disk space goes very less. So I'm not sure whether that disk space is referring to my Google Drive, or there is a small VM in the backend, which is, I think, stuck somewhere. So I'm still I am, for the last 2 days I tried, I think, on a Thursday to check whether I could mount my drive. I couldn't. So I didn't do anything yesterday. I didn't do today. So I'm probably going to start doing it tomorrow. And the reason being, they say after every 12 hours, they clean the GPU or your whatever resources has been allocated for your GPU. So
I
that's
see.
where I stuck downloading the data. Unfortunately,
Yeah, it
no
was a
shortcuts.
pain for me too. It took me several days to get past. And actually, I finally I'd left it running. I thought, oh my God, I left it in, it probably crashed, but I was positively surprised when I came back and found that the that it had completed and it had obviously the test files comes out very quickly, but the training files is where it gets into uh,
Correct.
issues. And I
Correct.
was surprised to find that it had completed successfully. So yeah, it's a pain in Colab. I had a question for Mehul because he had Mehul, were you able to successfully access the data on Kaggle itself, or did you unload the data on Kaggle and did it work for you? Or
Run the kernel on Kaggle. I'm just checking. Before I left, I used that. Like I
sorry,
have a
you're
local.
very faint, Mehul. Can you increase?
Yeah, is this better?
Yes, lot.
Yeah. Um, yeah. Before I ran only on the Kaggle kernel, and I did. I have a local machine, so I used that. The Kaggle CLI to download it.
Right.
I'm just checking. Um, I'm just checking when I unzipped what happened. Just one sec. I take with the CLI. I didn't have problems
Yeah,
getting.
download is not an issue, as
Uh,
Dinesh also said. Download works, but it's the unzip that took
I see.
hours
Okay.
on Colab at least.
Um, yeah, the zip file was 18 GB, and let me see the zip and the. I think I was able to unzip it, and I got the test folder is
Yeah, the test comes out quickly. It's the train that
train.
causes.
Oh, I see. Okay, okay. The test is just 4.5 GB, and
Right, right. Yeah,
uh,
it's the train that's the problem.
uh,
So it
yeah,
looks like it's a Colab. That's why I was curious. But then again, in your case, you had a
yeah. I had access to a Linux machine where I could download it,
download and unzip.
unzip
Okay.
it. Yeah,
Okay.
and
Any
Yeah,
anybody
I've
else?
had similar problems. Um, yeah, like I tried to download the data, following like everybody's instructions and getting the zip file, and eventually I did manage to get it onto Collab. But then when I ran the notebooks, it appeared to be really slow. So I've just gone back to Kaggle and using it on Kaggle by itself, everything seems fine.
I
So
see.
I've just been running on Kaggle, and it seems to run a lot faster. The only problem I would have is you've got like the 30 hours per week GPU allocation. So at the minute I'm trying to do stuff just on CPU for all the sort of the main workaround, and then actually run the network, the CNN itself on the GPU just by itself. But yeah, out of that I've got some reasonable results now.
Okay. So maybe you can share what you've done because I don't think anybody else has been able to make much progress, Steve. So maybe you can just mention what you have tried, and then I had posted last week some thoughts on various aspects, but you can present what you've been able to do, and then this week maybe all of us can try and catch up.
Yeah, so I was using, do you know, like the Jovian thing that I can't remember who mentioned that a couple of weeks back.
Mehul did.
Yeah, so like with it, it's been quite useful actually for sort of recording recording results and sort of seeing what you get. So I've really only run two different sort of types of workbook. The first one was taking the 4-channel images and converting them into RGB. The trouble with doing that on Kaggle, it didn't really have enough memory to go at like 512 images. So it's like running at 256 images. Then I found like within Fast AI discussions, somebody talked about actually handling the 4-channel images themselves. So I've started now to like use the 4-channel images rather than converting them to RGB. And doing that is like sort of nearly doubled the performance I can get.
Sorry, what's that again? I missed handling it as what?
Handling the 4 channels separately. So
I see.
Putting the 4 channels individually into the CNN rather than converting to
RGB.
Yeah, I'm not sure if I can share my screen. I might be able to show you what I've done here.
Yeah, that'll be great. Yeah, just if you can share your screen.
I haven't done this before, so
yeah, that's fine. Yeah, it's the bottom. Yeah.
Yeah.
I have a quick question while we're waiting. So do you know, like, if somebody already like unzipped the files on Google Drive, are we allowed to share it outside of Kaggle? Like, if the step of unzipping is more difficult one, if I think Srinivas said you already have it unzipped on Google Drive, can you share just that directory?
Yeah, that's a good point, Yuri. Let me see whether I can do that, and I'll definitely may not be today or tomorrow because I'm on the road, but Monday I'll definitely look at that. That's a good idea if I do have it on my Google Drive, and let me see whether I can share a link to that or and just that part. That's an excellent thought. I'll follow up on that.
Thank you.
Yeah, sorry, this is just going to take me a minute to fire this up.
Yes,
I forgot it.
go ahead.
I forgot to change my computer.
Yeah, that's a good idea, Yuri. I'll definitely look into whether that. I don't think there's any restriction because it is just data. It's just more of can we just share to that. I don't think from a Kaggle perspective there should be any problem because they anyway allow you to access the data and download it. So I'm assuming that shouldn't be a problem. For Kaggle, it's just me sharing just that part that I have to figure out.
Thank you.
Yeah, while Steve shares the screen, yeah, when I download on my local machine and the unzip works, and I have, I think it's like 31,072 files per channel, and it's like 14 GB. And I just did some regular Unix unzip, but there are a lot of files. So 31,000 in the 31,000 times 4, so 100 and whatever, 24.
Yeah, that tallies roughly, if I recall from memory, how many images are there in the training set.
Okay.
If you go through the kernel things, it seems to suggest there are about 31,000 images in the training set. That's what I vaguely recall.
Okay.
I don't know. Can you see that?
Yes.
Can you see my screen now?
We can.
Yeah. Yes. Yeah. Okay. So this is like both the notebooks that I've created. So I create these on Kaggle, and then share them onto Jovian. I commit them over to Jovian. So you can see here. Yeah. So I've got like 2 commits that I've done.
Yes.
So with it, so you can compare the versions and see how each of them's done. Yeah, so these are the 2 I've run. So the first one was this RGB 256. And like that's where I take the 4-channel images, convert the yellow, the red, the green, the blue just into like a standard RGB, and then just handle it like a normal CNN. Whereas the second one, this is the one I've done individual channels. So yeah, so look at this one. Yeah,
the 0.42 is pretty good result given that the winning entry, I think, is 0.54, if I'm not mistaken, or
Right.
0.5 something.
That's right, yeah. And so like here as well, it's like it's not doing anything else to it. It's just purely sort of sticking it into the CNN. So yeah, like in the notebooks here, yeah. So like including like Jovian, including Kaggle. Yeah. So this is the 256 one. So it's yeah, just
But this is 256 with 4 individual channels. Is that right?
no. This is the RGB one.
Oh, this is the RGB one. Okay.
Yeah. So you can see here. So these are the images brought in the 4 channels and then converted to RGB. So you get some nice pictures out of it. Yeah, so you can see, yeah, it's calling a function I've written here to like resize them. As I say, I had to resize down to 256, otherwise I ran out of memory.
I see.
Yeah, so here it's just your standard fast AI loading up. So it's like loading in the new RGB images that I've created.
Okay. Sorry, Steve, just to interrupt, and since I wanted to mention something I recalled, when I was trying to unzip, actually, strangely enough, Colab came back and asked me whether I wanted to increase the memory, that size that I was using, that I was pleasantly surprised that it did that. And actually I said yes. And that seemed to factor into the fact that it successfully unzipped, just for reference.
All right. Yeah, as I say, I ended up, yeah, like it took me a few days. It took maybe 3 days or something, and eventually I got the data in. But like then when I started actually trying to use it, it was just so slow that it wasn't producing many results.
I see.
So this notebook here is the one where it actually uses each channel separately.
I see.
So in this here, yeah, so like this thing, it's using a 4-channel ResNet, which I haven't looked into all the details of this. This was just something I found. It was actually on the Fast AI website. Oh, by the way, because of the fact that this is in Jovian, and it's like a public notebook, so I think like any of you could probably go to this web address. If any of you go to this, you can like actually see the notebooks that I have. And the other thing is, so here, so again, those are the 256 images. Whereas if we come down here, you can see now this image here, this is actually where it's like treating it as a separate channels. And so I don't know why they come out white, but they do. So again, and here now what we're doing is, in this case here, it's set it up so as it uses like the function. So it's created the image list as like it normally would in Fast AI, but like this part here, it's like specified like the special function to keep the 4 channels separate.
Right.
So like when the data bunch gets created, so it keeps them separate. And here you can see like this is the data bunch being displayed, and so each of the 4 channels is coming in. And with this, so there's not a lot of training going on. There's the learners. This is like a Jovian callback that I've created. Again, like it's like their standard thing, but what this does, the Jovian callback, and there's a save model callback. Here, I've wired these callbacks up onto the Fast AI learner. So as training's progressing, it's like populating like its Jovian structures, so as it keeps the details of its training.
I see.
So here we can see like there's just like fitting 1 cycle. This is like the frozen network. So the F beta is gradually going up. I probably could have trained there a bit longer and gone further. Then just the standard, like then unfreezing it and doing it again. And you can see here, so like this is this part here is like Jovian showing it's like recording the stuff, and it's like looking, it's got the other callback to keep the best model during the training. Yeah, so it was just like 10 epochs, and at the end of that, yeah, so like this is creating the submission file, and then finally, like once I've created the submission file, then I called the Kaggle API to submit it to the competition. Then I ask for my scores back again, store them into this results file, and then in this point here, I read the results file back and like log them into the Jovian metrics, which then at the very end of the thing, when I commit to Jovian, it takes the public and the private scores that I obtained for running the notebook, and that's what slows them up. So, so if I go back here to, yeah, so there's, as I say, I've only got like the 2 versions at the minute.
No,
so this
is awesome. Yeah, I knew you could submit it, but I didn't know you could like get the results back.
Yeah, like no, it's like something I just sort of found this week because previous, but yeah. So here's the things populated into the spreadsheet. Yeah, because I previously what I was doing, I was like submitting it to the Kaggle competition, and then like I was like manually having to go and find the values and then type them in. Whereas like this like does the whole thing automatically.
This is awesome.
Yeah, this is great. I think either and you and we made substantial progress, so that's good to see.
As I say, though, there's 2 differences here. So like one difference is the fact that I've gone from like using RGB into using 4 channels. So there's the RGB and yellow. But the other difference is this one here was just working on 256, whereas like this is the original image size, which is double at 512. So at the minute, what I was doing, I was going to like work on resizing the original images to keep them in their original 4 channels, but to use different sizes, which would let me do sort of, like where you start off with small images and train your network and then gradually increase the image size.
Yeah, in fact, exactly. I was just going to suggest that would probably be the really good thing to try. So it'd be great, if we did it on 256, for example, and then move to, or 224, then increase it eventually.
Yeah, I wanted to do on 256 because that would give like a better comparison against this one.
Right.
Yeah, because at the minute I don't know, is it because I've gone to 4 channels I get much better results, or is it because of the fact I've doubled the image size I get much better results? So that's what I was going to try during the week.
Right. Yeah, that, and as you said in your comment, that plus augmentation itself. And what loss are you using on this? It's just binary cross entropy with legits, or?
Well, yeah, I've just got like the F beta loss on there. So yeah, I tried that. At the minute, it's just like the standards accuracy and loss that's on it. Because I had tried the cross entropy loss and it was giving me another problem. So I hadn't sort of investigated that further.
Hang on.
Yeah, so you can see here, here's the learner here. I had tried this thing. This is like the loss that had come in from the example I'd found. As I say, up here. Yeah, so like here's the details of like where I got this 4-channel code from.
Right, right. Yeah, I'd seen the kernel for this. On the Kaggle stuff. Yes. Yeah,
so like within that, they'd sort of talked about the loss, but I hadn't had a chance to really investigate into that at all yet. I was just trying to get some results out.
Yeah, I think your image size, plus image size starting small and then increasing, and then another variation would be the augmentation, and the third thing to try would be the loss, which would be just the binary cross entropy loss, and then combined with focal loss if possible. Those would be the things to try from where you are at already.
Yeah. Yeah. So at the minute, it's just, as I say, it's like it's taken me a week or so to actually get any data and get some results out. So at the minute, it's all just a baseline. But
Yeah, no, this is excellent because I think I was hoping to get a few steps along the path to where you are, but I couldn't do anything this week. So hopefully we'll all be able to make some progress this week and get some results similar to what you're seeing.
yeah,
And it'd be interesting for me even to see, as you mentioned, whether collab works or is it too slow and I would have to, if so, then maybe this thing doesn't work in collab at all and we'll have, at least I'll have to change. But that's something worth trying this week.
yeah, definitely, yeah. So as I say, like I think that anybody could go to like this web address and
Yeah, if you could just post that maybe on the Slack channel, then that'd be helpful.
Yep. Once you're in here as well, you can go into like this run thing. So like you can ask it to like, obviously you can't run on Collab if you haven't managed to get the data down there, but you can click on this and run on Kaggle, and it should load it up into your Kaggle. So
interesting. So you mentioned you tried the binary cross entropy loss, but it gave you it didn't work, or what problems did you run into?
Yeah, so down here, yeah, so you can see here like this thing. This learner here, this is the one that had come out of the person's post about using the 4 channels. So like originally I'd just like taken this as it was, and
right.
For whatever reason it gave me an error within there somewhere. Like I wasn't sure what this cut -2 and things are. Yeah, so I just reverted to like my basic, like the FastAI basic CNN learner.
Yeah, by the way, that itself, if I can't access the FastAI source code and stuff from where I am, but I believe if any one of the other folks can do it, I suspect that the basic CNN learner itself potentially is using, I don't know whether it's using a binary cross entropy because this is a multi-channel stuff, but then again, if it weren't using it, you wouldn't get the score you're getting. So I would venture to guess that it's probably using binary cross entropy as default, but I'm surprised it is that it is that. But it's using some loss function. It'd be interesting to know what loss function it's using for CNN learner default.
Yeah. As I say though, like it is, I have like the F score coming in as the metrics. So I'm just recording that.
Yeah, accuracy and F score, but it's obviously using some loss function as a default for CNN learner, and I don't recall what it uses as the default. It'd be worth going and checking that in the FastAI source code.
Yeah, no, like that's something I need to look into. Yeah.
Yeah, because I think if you can get it, maybe it is already using binary cross entropy, but if you can then combine it with focal loss, as Mehul went through in one of the previous discussions we had, that'll also help boost the case of, because of the class imbalance, it'll help, and the fact that it's a multi-class problem. So using focal loss together ought to really, I'm hoping that just changing the size, doing a bit of augmentation, plus using focal loss in combination with BCE should itself get you even better score than what you have right now.
Yeah, sure. Yeah. So Yeah, there's like a load to work on yet.
Yeah. No, but you've made fantastic progress. That's great.
Yeah,
Good to see.
I'd actually missed like the last couple of weeks. I wasn't able to like join in, but I heard it had been recorded, but I still haven't managed to find a way to see the previous week's
Yeah,
recordings.
Mehul was following up. Mehul, did Mia get back in with respect to the recordings?
No, I put a note on the study group, host groups, and I think even Joseph was following up with her, but we haven't
Yeah, I
heard back.
believe Joseph was able to get access to the NLP recordings. So if
Okay.
you could maybe send a note to Mia and ask her whether these are, I do see the little red thing flashing as soon as
Right.
we open, and even today you can see the recording thing flashing on the top left. So if you could check with Mia on whether the recordings are available and where, and post, I believe they ought to be, but I don't know where they are. And since you are following up, I didn't want too many people pinging her at the same time.
Yeah, I'll follow up with her right now after our call. Yeah.
Okay. So then, Steve, Mehul will post about the access that you're talking about.
Okay, cool. Yeah, it'd be good to catch up with the ones I missed.
Yeah.
So I think a few weeks ago, Srinivas, you talked about that transfusion paper from Google.
Yes.
Transfer learning. Because here we are. Here, Steve, you used like a you did transfer learning here.
Yeah, it's using it's using a pre-trained ResNet.
ResNet, okay.
Yeah, and he's using transfer because the 4 channels he is. By the way, that brings up a good question too, Steve. I believe in this particular kernel that I was thinking of, Mehul, to your point, if you look at what he has at the top, the M06, M1, the ResNet split, that's splitting it and loading the pre-trained stuff on ResNet. And also question, Steve, is this ResNet 34 or 50 or?
I think it's 30. Oh, it's 50 actually. You can see here. Yeah, so it's like
ResNet 50. Because one thing you may want to also try, I saw on multiple kernels, is interestingly 18 or 34 gives better results than 50 does for this one.
right. As I say, where's it going?
Because I think you specify that.
Yeah. Oh yeah. Yeah. So like, this is the 4 channel ResNet that, again, like as I say, I just took this out of the other person's post.
Right.
Yeah. So.
The encoder depth part, it's 34. So it's actually using 34.
Yeah. Although, as you saw, like down below, it was downloading the.
Yeah. If you go down.
Yeah. So you can see here, it's like downloaded the PyTorch.
Oh yeah, it's taking in ResNet 50s.
Yeah.
Arc is, the arc specified as ResNet 50. Huh.
But yeah, so bye.
That's interesting. Yeah, I thought they would match.
Yeah.
Yeah, but see, the thing is that, you'd have to dig to the code to see whether he's using 34 or 50, because one place seems to say 34, the other.
Yeah, it does. It's like seems to have like loaded the ResNet 50 weights, yet specified a ResNet 34. But yeah, I need to look into that and see why it's doing it.
Yeah, because to Mehul's point, what we had discussed and the paper is referring to seem to suggest that simpler models, simpler ResNet models, and in fact, simpler models in general seem to yield better results for cases such as these with medical images. So that's why I was curious whether, if you tried it with 34 or even 18, whether it actually improved the score, because that technically ought to be a fairly simple change, but
Yeah.
you'd have to go through this code to figure out is it actually using, which of it it's actually using.
Well, I see here, like when it actually creates the instance of it, you can see here it's actually passing in an encoder depth of 50.
50, yeah.
So yeah, although the default for that code is 34, it is specifying 50. So that's why it's doing it. But yeah, certainly that's another thing I could try is like varying the encoder depth to see what that does.
Right. Yeah, 18 and 34 seem to. And by the way, the other, since we are on that subject, the other variation, and I posted on this is among the table that I had created and posted last week.
Oh yeah, so like, yeah.
Right. Is the other variation, which also in the Kaggle kernel discussions, it says that yields better results. And it's a fairly simple change if you're using fast AI, is a dense net instead of a rest net. But what I don't know and worth figuring out, maybe anybody on the call can look into this and I'll make a note and check, is whether there are also pre-trained dense net available.
Yeah.
Yeah, that's good too.
Because DenseNet basically, as I was saying, I think last week or the week before, is and Jeremy goes through it in one of his version 3, either the last or the second last lecture of the part 1, is essentially instead of in RestNet, you have the residual connection. So it becomes X plus f of X. And you add directly from the input, and in case of DenseNet, you concatenate rather than add for every input level. So instead of doing X plus, it becomes like, the combination X and the convolution layers are combined and then input into the next level, into the next layer.
Yeah, I think as you say, like in the original paper or the paper about the winning solutions to this Kaggle competition, I think you're right. I think the people who sort of won the competition were all using dense nets.
Right. So it made, and with fast AI, it's fairly simple change to use the code. Of course, we'll have to figure out, the ResNet 4-channel code that you have it on right now. How it ought to be fairly simple to convert this to a dense net.
Yeah, that's what I was wondering. But yeah, it looks as if sort of the main code's simple enough. I think it should just be a case of changing the encoder to dense net and keeping the rest of that the same.
Right. And then the only question is, is the are pre-trained weights available, which I believe it ought to be, because it's a fairly common configuration as well.
Right. That's another thing to add to the list to check out.
There's quite a bit that I posted on the table.
Yeah.
That there's lots of variations to try.
Yeah.
This is great. Like I think I have one more addition. I think last week there's a new paper. There's a journal called Radiology AI, and they have a paper on this issue about pixel size, or I think they, like how we were discussing, like 256 by 256. They have the whole paper is about what image size and pixel size to use with transfer learning. And I'll try and share the PDF on the channel. Maybe it might have some good ideas or more experiments for us to try. Yeah, I was surprised, like the whole paper is about that. Like, so.
Right.
Yeah, especially in medical image training, even the transfusion stuff made some very excellent points about, the applicability of transfer learning and which parts of transfer learning really matter for medical images.
Yeah, I haven't looked into FastAI's V2 code yet, I was sort of just like skimming through some of the posts on that, and I noticed that the version 2 code of FastAI has something specifically targeted at medical images, but I don't know what it does or what it is, or if anybody's used that.
No, I haven't used that yet. But I just thought of something. So in this case, you did you do any? I think FastAI has some data augmentation features in.
Yeah, it does. Yeah, but no, I haven't applied any augmentation at all yet. Like at the minute, it was just a pure baseline because I was going to sort of start adding the augmentation sort of one thing at a time just to see what effect it has.
Makes sense. And my one more question was, I see, like this is version 7 of your notebook. So when you had the two models, like 3 channels versus 4 channels, you didn't make separate notebooks. If you keep it in the same, then you can compare them easily, right? Oh, you do have 2 notebooks. Okay.
No, it's like basically each notebook had sort of specific stuff, one for RGB and one for going for 4 channels. And to make things simpler, I just, like in Kaggle, you just edit and fork your kernel or whatever and make another one. So like each time I was moving on. You can see here, well, you can't see here, but so there's only 2 showing up here because of the fact I probably had 7 or 8 different kernels when I was experimenting, mostly sort of with the Jovian thing and with the Kaggle bits to get information in and out. So I just deleted all the rubbish ones just to leave these 2, which were the sort of the proper results of each of these experiments.
Okay.
But so pretty much like when I would go from sort of one main sort of type experiment onto something completely different, I would fork the notebook and leave the other one behind.
Okay, and you could, I see. So this comparison can be done across notebooks. That's really nice.
Yeah, no, it's cool. It's like the fact that the only trouble is like Jovian has a problem. It can't commit it can't commit the notebook or the results during a Kaggle commit. So I actually had to do some stuff so Jovian doesn't do anything when the Kaggle commit's taking place. Because what it does is it wipes all the output of your cells, and so you don't end up with anything in the output.
I see.
So you can see. So I wrote this function here, which is the Jovian commit thing that I call at the bottom, because when the Kaggle commit takes place, it actually changes the name of the notebook that it's working on. So
I see.
So you can see here, if the name of the notebook has become done the notebook, that means it's a Kaggle commit, and so I don't do anything then. So it means that the actual commit over to Jovian, I have to go into Kaggle and then click on the run all button to run all the cells in one go, and like that populates all the output cells and like submits over to Jovian. And then when I'm happy with the notebook, I would click on the Kaggle commit, but it doesn't do anything to Jovian. For the reason I said, that it wipes everything, so you need to be careful with that.
Okay. And how much in these experiments, how much of your Kaggle limit did you use up? Like, I think it's 30 hours per week.
It is, I would sort of start on a Monday, and I would have probably run out of my Kaggle limit by Thursday, maybe. But
I see. Okay.
A lot of the time, I'd be sort of. The reason I'd be running out was because of the fact that half the time it wasn't working, because like the Jovian commit wasn't working, or I don't know, something else wasn't working. Where I think like now I've sort of got the process ironed out where I can actually run the notebook and submit it in the way I want. So hopefully now I can be a bit sort of smarter with my GPU time so as I don't run out. And as I say, like at the minute I want to like try resizing the images. And what you can do within the Kaggle kernels is I can like run one kernel, resize all the images, which will write it into the output for that kernel. And then I can load that kernel into a new kernel, which actually does the training of the network. And so I can run the 2 separately, and like the resizing of the images, you can do that in a CPU-based kernel. you don't need to use a GPU for that. So by separating the image resizing from the actual training, then a lot of the time that currently is being spent, I can not do that on the GPU kernel, and so hopefully save some time that way as well.
That's a great idea. Yeah, I see. Yeah, that if you can load one kernel into the other, that's awesome.
Exactly. Yeah. So and it means resizing. It takes a long time. So if you're going to do progressive resizing, you can like create like a load of kernels, each of which is doing a different size of image, and then load each of those into your final kernel. So you don't have to do any resizing when you're actually training them.
Right. Yeah, I think I did something similar for one of the Kaggle X-ray competitions. But I was using a local machine, so I would have the resize separate and have folders like 256, 512, 768.
Yeah. The other thing I found, like I did like another Kaggle competition, and like what I found is if you go into Fast AI and you tell it to do like data augmentation, but you also specify like an image size in there.
All right.
If you do that and your images aren't at the size that you specify, it'll do the image resize when it does the augmentation, and it becomes really slow again. Whereas like if you resize all your images up front and then do the augmentation separately, you get like a big speed up on it.
Okay.
So it's best, what I found is best is not to let Fast AI do the resize for you.
I see. Okay. Makes sense. This is great. I think, like Srinivas said, we are all going to try and catch up to you this week for next week.
Yeah, the hardest part is actually getting the data together. So once you actually have that, then it's you can actually get down to work on doing the experiments.
Mm-hmm. Okay.
Yeah, and also what's impressive, I think, and it kind of confirms what Demi says in some of his discussions. Your 0.46, and with some of the changes, if you're able to get to 0.5 something, 0.5x, it also shows that some of the sample size differences, you didn't do anything for them, and it's still giving really good results. By that I mean, the imbalance doesn't seem to matter a whole lot if you can get it way up to 0.5 plus with just a few more tweaks like augmentation, incremental sizing, better law or different laws and that type of stuff. So which is interesting because with the level of sample imbalance, you would think that you would have to do something for it, but it doesn't seem so.
Yeah, no, I definitely like so far I've got like reasonable results without doing anything special at all. So yeah, hopefully once I start Andy, like a few sort of more tricks or whatever, then we should be able to get to 0.5.
Yeah, that seems very interesting because I was thinking, you'd need to probably do some oversampling of the underrepresented classes and stuff, and maybe in the final thing to boost it, but it doesn't seem like to get a healthy score like 0.5 something that it's necessary, which is interesting.
Yeah, well, certainly I'll try and get to 0.5 this week if I can.
Yeah. Also, the other thing in just poking around with the kernels that I saw, which is interesting also, is just like you did the 4 channels, some people have done it, instead of converting to the 3 or using all 4 channels, some have just used 3 of the 4 channels and including thereby the the R, G, and B, and just dropped the yellow and still gotten pretty good results.
Really? Yeah. All right.
So in your case, when you did the RGB, I stared at that code last week, I think, and you had kind of converted the yellow into, or you had used the yellow and then converted it, I think, to an RGB. Is that right?
That's right. These images here,
Right.
these are the RGB images. So yeah, you can see yellow's in there.
Right. And what was interesting was some kernels I saw when I was poking around, not last week, but before, and you may want to try it, it's a different RGB version. Just use the individual channels, but just drop the Y. Just use the R, the G, and the B from the images.
Right. Yeah.
And obviously, you'll need to adjust the transfer thing as well.
Yeah.
And the image stats data. But if you did that, apparently people were still getting pretty good results. And, it also speeds up processing.
Yeah. I'm surprised about that because I thought the yellow channel was the actual proteins themselves. And
that's the green, I believe.
Oh, right. I thought it was like the yellow was the proteins and the green was like sort of the cell. And it was like, yeah, the yellow was the thing you were trying to identify whereabouts in the cell it was.
Hmm. But but I definitely recall seeing that, people had done just drop the yellow and get RGB and do it. And they were getting in the high 0.4s.
All right. I can try that as well. Another one to add to the list.
Yeah.
Yeah.
Okay, great. So, this is really great, excellent. Thanks for sharing.
No worries.
If I repeated, we'll all try and catch up, and hopefully you can blaze forward meanwhile. And also to Yuri's point, I'll try and see whether I can share the link to the unzipped data. And of course, I still have to work on the data. I haven't really used it. So as you pointed out, that it may still be unworkable in Colab, but I'll look into that and see whether I can share the link to my Google Drive, which has the unzipped images.
Thank you. And I need to sign up pretty soon. But
Okay.
Steve, thank you it was great.
I think all of us probably. Anything else from anyone? Mehul, if you could follow up with Mia, that'd be great, and post.
Yeah, I'll follow up with her, and I don't have anything else. Thanks, Steve. Yeah, this is great.
Yeah.
Okay.
Thanks a lot. See you guys
Cheers.
next week.
See you next week.
Yep. See you next week. Bye.
Thank you. Bye.